Change recording.
Okay, I'll send. Good morning. Okay, are you able to hear me now clearly?
Yes.
Yes, please.
All right, so I welcome you to today's session in econometrics, where we are trying to learn how to, to analyze the outputs and interpret the outputs from stata, the stata output. So just as I said yesterday, what happens is that you command the stata in some particular pattern, and as you command the stata, the output will come out. Okay, so we assume stata was commanded, and this was the output. This was the output. The question was of the output that was showing the regression of various categorical dummy variables. So the model shows the relationship that cost incurred by schools have with the number of enrollments done. There are regular and the occupational schools. However, regular schools have two categories. There is the general and the vocational schools, whilst the occupational schools have technical and skilled workers schools. So the output was generated here. Okay, just a minute. Yes. So while the stata was commanded, then the output, there was this output that we got. So the question, what we are required of doing is to analyze the output and interpret the outcome. Is the class being recorded? Okay. So where do we start from? Let's start from analyzing the the coefficients. Okay. So you have the coefficients here, right? These are the coefficients that you have. And just as I did say, this one that is written here is the y variable, right? We are looking at the impact of these other variables on the cost that is incurred by schools. So our cost is our y. Then these are the other variables. So to start with, this one is the constant, right? This one is the constant, which you may call the beta naught. So the model has got how many variables, independent variables? There are 1, 2, 3, 4. So it is of the form y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus the beta 3 x3 plus beta 4 x4. They're how many? They're just 4, right? 1, 2, 3 plus 1, 2, 3, 4. Yeah, they're just 4 independent variables. Okay. So the model is this one. This one is the constant. Okay, is the constant. That's the beta naught. So you can write this as y is equal to 469.29. The constant, the beta naught. What this means is that the interpretation would be, you keep other factors constant. If all these other variables are zeros, then the cost will be what? The fixed cost is 88,469.29 units, which simply means if those units were kwachas, for example, assuming the units were just kwachas, Zambian kwachas, you would say the fixed cost will be 88,469.29 ngwe. Is that clear?
Yes.
Number, is that okay?
Yes, it is, please.
Then we can go to the next one, which is our beta one. Okay, remember the constant is still here, the beta naught. The beta one is, let's get the, choose this negative what? This is negative 143,362.4, right? Yeah, 0.4. So what this means is that a unit increase, these are enrollments that you're looking at, right? As you increase the enrollment by 1 unit, or as you enroll 1 student in general schools, GN is general schools, in general schools, right?
Sorry, is it a negative 1.4 or 4.4?
Yes, it's negative. Oh, negative
No, but
1. Negative 1, aye? Negative 1, 4. Yeah, thank you. As you increase the number of enrollments, okay, by adding 1 extra student, then the total cost reduces by 143,362.4 units. Is that clear? So as you increase this one, then the variable in general schools, then the cost reduces. You got it, right? So the total cost reduces by 143,362.14 ngwe. Okay, so the cost is reducing because you have added more students. So this is what happens. So what happens is that, in short, the more students you enroll, then the lesser the costs, isn't it?
yes.
Yes, it becomes cheaper to enroll many students because just look at the cost that you have. You have the fixed cost, this one. It's a lot of costs. That is just fixed. This one simply means whether you have 0 students, you have to incur this one. Probably you could assume maybe it's the cost of rent or something, okay? So as you start now increasing the number of enrollments, then the fixed cost does what? The total cost reduces. Is that clear? That is in general schools. We can get beta 2, which is the vocation, under vocation. Y is the total cost. Then we have the beta naught here. We have negative 90,133.74. Yeah, beta 2. And our beta 2 is what? It's vocational schools, right? These are vocational schools now. So you would interpret it like this. You say holding other factors constant, isn't it? Or holding other variables constant. A unit increase, of which the unit that you're talking about is what? The number of students, the number of enrollments. So an additional enrollment in vocational schools will reduce the total cost by 90,133 kwacha 74 ngwe. Is that clear? Hello?
Yes. Yes.
So I'm using kwachas. I've just used the kwachas to make it a little bit practical. But if you're not given the units, you can just be saying unit, isn't it? You can say, but the number of units are specified. These are number of enrollments. So an additional enrollment, okay, in the vocational schools would increase what is this? Would reduce, this is negative, the total cost by 90,133.74 units. Okay, because the units have not been specified. You can just say units, but the reason why I was using patch, I was trying to be more specific a bit in case the question is specific. Any question?
So far, so good.
All right. Then
So
we can have.
Just a question.
Yes, madam.
This formula that you're writing, the y is equals to beta 0 plus beta 1
Yes,
x, or yes, please. We have to put in the figures as we go by.
you can put the figures, then you start interpreting. Holding this, it's just the general model. I just didn't want to put them since they are already there.
Okay, I see. Yes, please.
Yes. Just fuse them in and then you're fine. And then you start interpreting, holding all other factors or other variables here.
Okay.
You can interpret this one, try again. At least you can try. Tech is the technical schools.
Beta 3.
Beta 3 now.
Okay. So maybe we can say beta 3, technical schools, huh? Putting all other variables constant.
Yes.
A unit increase in technical schools will increase the total amount by 10,748.51.
Okay, thank you. Just that. Okay, but you were so general a bit, but it's okay. You were general. I want you to be more specific in the way how you select your words. Would you try again? Just in the same line, but maybe you can use more specific. You can try to be more specific.
Okay. I think it would be the same. If we're holding all other variables constant, a unit increase in the number of enrollments will increase the total cost of the tech by 107.48.51 units.
That's what I wanted to hear. Like, you don't just say the total of the amount. It's amount of what? Is it the amount of revenue? Is it the amount of what? So specify, right? In your interpretation, let us hear the independent variable and the dependent variable. They should come out clear. Like, you get it. We have to here specify the independent variables and the dependent variables. Okay, just as you said, an additional enrollment in technical schools would increase the total cost by 10,748.51 units. Isn't it? Just as you said it. It was okay.
Okay, thank you.
Any other try on this one? We are interpreting the coefficients. On the other one, n is what? What schools do we have here? We have what schools do you have in the question?
Vocational and
There's
general.
vocational, general, technical, and what?
Fields.
Oh, skilled, yes. The skilled schools, skilled workers. Any interpretation to this one?
So N is skilled?
Yes.
Okay. Like I say, holding other variables constant, an increase in skilled, is this just skilled, is it?
No, it's a school of skilled workers. You get skilled workers school. So it's the enrollment that you're talking about. Just continue.
Okay. So it will how about this? Holding other variables constant, and
Yes.
an increase in skilled enrollment by 342 342.6 will impact the increase in a beta 4.
Okay. So thank you very much. So what is there is you would also put it like this. You would say an additional enrollment in a skilled workers school, or an additional enrollment in a skilled workers school would impact the total cost, or would increase? Because if you say impact, that's general again. Is it reducing? You would say it would increase the total cost by 342.63 units. You got it?
Oh, okay.
Yeah, so it's the other way of putting it anyway. So let us here, the point is that let the independent and the dependent variables come out clearly. Yes, when you're interpreting, we should be able to know that, okay, this one is the impacting variable. Is there any question on how to interpret the coefficients themselves and the yeah, their impact? Any question? Okay. Assuming that the silence means it is well, then we can move on to hypothesis testing. Are you able to hear me?
Yes.
Yes,
Okay.
please.
So with the hypothesis testing, what are we aware now, that was regression. That was linear regression. But now we are going to hypothesis testing, where we are forming the hypothesis and try to test the impact or the significance of these variables to the model. At 95 level of confidence, or 5% level of significance, which of these variables are significant using the t-statistic? Maybe just a quick reminder, at 5% alpha, which is the level of significance, the critical value of t is 1.96, just that. So which of these variables are statistically significant to the model?
Maybe the N, the 8.519, and yeah, I
And
think,
the 3.0, what's that?
but that one is a constant.
Oh, that's a constant. Okay, sorry.
So I don't know if a constant impacts the this one.
Okay, yeah, you also test the significance of the constant.
Okay.
Whether the constant is properly, like it's the true one, it's a true constant. Again, you test its significance as well. Very, very important.
Okay, then it's the two, the N and the constant, the 8.519, beta 4, and the constant.
Okay, it is significant.
Yes.
What about the other variables?
They are less than 1.96.
Okay, they are not significant.
I'm still not getting this one. When it's greater than,
Okay.
no, I give up on this one.
Okay, so remember this bell-shaped data distribution that I talked about should be yesterday. I said that, just reminding you from statistics, This side you have negative 1.96. This side you have positive 1.96. This is the rejection region, and this is the rejection region. The in-between is the fail to reject region, isn't it?
Yes.
Right? So, following this, which of the variables are statistically significant? The one where the T statistic falls in the rejection region. Which one are these?
0.352 and minus 2.652.
They're significant.
Yes.
Okay, thank you. All right, so when you observe, when you look at this, let me start with the first one. The first one falls somewhere here. It's rejection region, isn't it? 8 point something. It's greater than 1.96. So it's in the rejection region. So reject the null hypothesis, right? The null hypothesis that says that this is not significant. Okay, so we reject it. So we say enrollments, right? The number of enrollment in skilled workers school has got an impact, or they are statistically significant to the cost, the total cost of the total cost that the schools incur. Okay.
Come again.
Yes. The null hypothesis says that this variable n is not what doesn't have an impact. Okay, it doesn't have an impact. In short, it is not significant different from zero. Like, it doesn't have an impact. That is the null. So the alternative is the opposite. So when you say you reject the null, in short, you are rejecting that this variable does not have an impact, meaning it has an impact. You get it, right? So this variable falls in the rejection region. You will say the enrollments in skilled workers school have an impact to the total cost that the schools incur, isn't it? Hello?
Therefore, we failed to reject it.
We reject it. If it has an impact, we reject it. The null hypothesis says it does not have an impact. So once this falls in the rejection region, you reject that it does not have an impact. When you reject that it does not have an impact, it means that it has an impact, right?
No. Sorry, Mandy. Come again.
No, it's okay. I am
Okay.
saying that the now says the variable does not have an impact, right?
Yes.
If you reject that statement, meaning you are referring to the opposite, right? If you reject that the variable does not have an impact, what do you imply? You're implying that the variable has an impact, isn't it?
Yes.
Yes. So that's what it means. When you check this variable, it falls, this figure, the T statistic is greater than what? 1.96. It falls in the rejection region. So therefore, you would say what? You would reject the null hypothesis, which says that this variable is not what? Statistically significant. That implies that the variable is statistically significant. You got it? Any question? So the interpretation would be at 95% level of confidence, okay? At 95% level of confidence, we reject, okay, the hypothesis or the null hypothesis that states the enrollment in skilled workers school does not have an impact. Therefore, enrollments in workers schools have got an impact or are statistically significant to the model. You get it?
You're a bit too fast. Go again.
At 95% level of confidence, okay, we reject the null hypothesis that states that enrollments, right, in skilled workers school, which is the N, have no impact on total costs. We reject that. Therefore, the enrollments in what? In skilled workers school have got an impact, or they are statistically significant to the model. Is that clear?
Yes.
We'll do more of those. Or you can still say at 5% level of significance, which is the same thing. Okay? You can use the confidence interval or use the significance level. At 5% level of significance, we reject the null hypothesis. Therefore, enrollments in workers' school are statistically significant to the model. It's still the same thing. You got it?
Yes.
You will be fine.
Just a quick question.
Yes.
Here we're using 95%, huh?
Yes.
How do we know that we're using 95%? Because it's like
here.
not. Oh yeah. Oh, okay.
It's always given.
Okay.
But mostly in stata, they use 95% because there are two things that we are avoiding. We're avoiding to make two errors. There is the first error, type 1 error, and the type 2 error. So these, they come with the size of what? Of the population, or the size of the confidence interval that you put. Okay? If again the size is too small, maybe you just put 90% level of confidence, you're most likely to commit an error. Okay? That is maybe rejecting the true null hypothesis.
Okay.
Rejecting the true null hypothesis. Again, when you reduce, that's if you increase the confidence interval, maybe you put it at 99%, meaning you're expanding the acceptance region, isn't it?
Yes. Okay, yes.
You are expanding the acceptance region. It can even enter to the rejection region, which means you're most likely to do what? To accept now the wrong what? The wrong null hypothesis, isn't it? Once you expand the acceptance region, which is 95% confidence interval, you expand the confidence interval, what is happening? You're most likely to commit type 2 error, where you fail to reject the wrong null hypothesis. Is that okay?
Yes.
The hypothesis is wrong, but you fail to reject it. Practically, you are supposed to reject it if it's wrong. Then similar, if you reduce this to somewhere 90%, meaning you are increasing the rejection region, right? What is going to happen is that once you increase the rejection region, you're most likely to commit type 1 error, which is rejecting the true null hypothesis. The null hypothesis can be true. Then because you have just increased, you have reduced the level of confidence and increased the significance level too much, you're most likely to reject the true null hypothesis, which is type 1 error. Okay?
Okay.
Any question?
So when we're interpreting the hypothesis, we're supposed to interpret only the T, not the P.
No, you can interpret the I'm teaching you everything now, but you can narrow down to the P value as well. Mostly that I recommend most of the time. You can use the P value. Yeah,
okay.
Not to suffer much. But when you look at your question does not specify. It just said analyze the outputs and interpret the output. You get, so it's just that open.
Okay.
That's why I'm trying to be open as well.
Okay, thank you.
So when you look at this 0.3 what? 0.352. This one is less than 1.96, right? It falls somewhere here. It is in the fail to reject region. If it is in the fail to reject region, it means that we fail to reject the null hypothesis, isn't it? Hello? You
Yes.
fail to reject the null hypothesis. Now, when you fail to reject the null hypothesis, what does the null hypothesis say? It says that technical schools have no impact. The enrollments in technical schools have no impact on the total cost. But yeah, that's what is there. So if you fail to reject the null, it means you are agreeing, isn't it? You are agreeing that enrollments in the technical schools have no impact on the what? On the total costs. Are you following now? They are not statistically, the enrollments in the technical schools, they are not statistically significant at 95% level of confidence. Is that clear?
Yes.
Then you come to this one. When you check this one falls this side on the negative. This is still in the rejection region, isn't it? Both negative 2.652 and the negative 5.142. They all fall in the rejection region, which means you reject the null, right?
Yes, we reject.
If you reject the null hypothesis, you mean that these variables have an impact on the total cost that the schools incur. Is that clear?
Sorry, come again. For if this one is, it falls on the other side.
It is in the rejection region too.
In
There
the
are two
rejection.
rejections, positive and the negative side.
So the HO, the null.
The null is still the same. It says that this variable has no impact.
Okay.
Now you reject it. When you reject that it does not have an impact, it means you're saying the opposite, right? It has an impact.
Okay.
You're fine?
Yes.
Don't worry, you'll be fine. We can now move to interpretation of the P statistic, the P value. For the P value, I did say this one is the easiest. They are consistent with each other. They are consistent. The way how you interpret on the P value, the verdict that you're going to make, or the ruling you make using the P value will still be the same when you use the T statistic. Is that clear? So with the P value, it says if the P value is less than 0.05, you do what? You reject the null hypothesis. Okay? Now, the rejection of the null hypothesis simply means that the variable has an impact, isn't it? If P is greater than 0.05, you do what? You fail to reject. You don't accept, you just fail to reject the null hypothesis. If you fail to reject, you mean that the variable has an what? Has an impact, isn't it? It is statistically significant to the model. Is that okay? Hello. Hello.
Yes,
So using the P value, look at the first variable. You remember the ruling that you made using the T statistic? Do you remember? Okay, you can interpret this using the T statistics again. You said you rejected, isn't it? Hello, am I logged out? Hello?
Yeah.
Okay. I'm saying that using the T statistic, we rejected the null hypothesis, isn't it? So even using the P value, this P value is less than 0.05. You know, 0.000 is less than 0.05. You are still rejecting, right? you reject the null hypothesis. The interpretation is the same. We rejected the null hypothesis because the p-value is less than 0.05 or is less than the level of significance. Okay? Because the p-value is less than the significance level, we reject the null hypothesis. That states that the variable does not, or the enrollments in the skilled workers school have no impact on the total cost. When we reject that, it means the opposite, right? It means that they have an impact. Is that clear?
Yes.
Yes. So you can observe that all the variables that you rejected, even here you are still rejecting them, isn't it? Have you seen the consistency? All these variables, you rejected them using the t statistic. But even here, you check they are all less than what? 0.05. You still reject. There is a variable that you failed to reject. The enrollments in the technical schools. Even using the p-value, this is greater than what? 0.726. It's greater than 0.05, right?
Mm-hmm.
So I said, if the p-value is greater than 0.05, you fail to do what? To reject the null hypothesis. Is that okay?
Yes.
So, any question? Any question? Okay. Is Nyambe around? Hello?
Yes. Yes, she is.
Nyambe, are you in class? She is not there. Okay. So now, you still remember on how to calculate, just as said yesterday, the standard errors, the t statistic, and other variables, isn't it? Interpreting is still not a problem. You're still able to remember, right? How to calculate.
That
I
was
said
T is equal to standard error.
coefficient over the standard error.
Okay. Okay.
That's how you get the t statistic. So it simply means that you can still get the coefficient using the what? The standard error and the t. Is that okay?
Yes.
Mm-hmm. Or we can get the t by dividing the coefficients by the standard what? Standard error. Is that clear?
Yes.
Okay. Let me come now to the interpretation of the R squared. Very, very important. Let me just start from the upper part. Okay. You've seen the number of observations. This is your n. They are 74. So it's like the total sample size was what? Was 74. Those are the number of observations that were made. 74. Okay. Then using the F statistic, they restricted 4 variables We just have four variables, right? We just have 4 variables. And then the degree of freedom is what? Is 69. So the F statistic is what? Is 29.63. That is our F statistic. Now, what is the F statistic? Okay. What is the F statistic? Just a minute. So the F statistic is it is actually it helps us to measure the significance of the model, right? The entire model, right? Just the entire model as a whole. Okay. So then the p-value, this one is the probability of the entire model, is the p-value of the model. Now, it indicates the reliability of the X variable to predict Y. So it indicates the what? The reliability of the X variable to predict Y. So usually we need a p-value that is lower than what? 0.05.
Right.
Okay. That is lower than 0.05 to show a statistically significant relationship between X variables and the Y variable. So looking at this one, it means that there is a statistically significant relationship between the what? These variables and the Y variable, because it is less than 0.05. Now, like all the models, like you're not looking at them one by one, no. Like you've consolidated them. Is that clear?
Yes.
Yeah, putting them together, all of them, that is what you get. Okay. Then you have got the R squared. The R squared. The R squared shows the amount of the variance of Y explained by X. I'm saying the amount of variance of Y explained by what? By X. In short, for this question, it explains the amount of the costs that is explained by what? The enrollments in skilled workers school, enrollments in technical schools, in vocational schools, and in general schools. So how much of the variation is explained by what? By the X variables. In the case of this question, the R squared is what? It is 63. Okay, 0.6320, right? Multiplying this by 100, what do you have? 63%, isn't it?
Yes.
This simply means that 63% of the variation or of the variance in cost, okay, is explained by what? By the X variables, which are the enrollments in skilled workers schools, technical schools, vocational and general schools. Is that clear?
Yeah.
So the enrollments in general in a skilled workers school, technical schools, vocational and general schools explain 63% of variance in total costs. Did you get the interpretation?
Yes, so let's come again.
So this is 63% simply means that it's the amount actually of the variance or the percentage of variance in Y that is explained by X. So remember that the X variables are there to explain the variances, isn't it? They are there to explain the variances in Y. What is causing Y? In short, they are there. So only 63% of the variances in total cost are explained by enrollments in skilled workers school, technical schools, vocational, and general schools. Did you get that one?
Yes.
I'm now being specific. If I were general, I would have said only 63% of what? Of variance in Y are explained by X variables. Now I'm too general because what are the X variables? You get it, right? And what is the Y variable? I told you that in your interpretation, let us hear clearly the independent variables and the dependent variable clear. Okay?
Yes.
Any question?
No, no question.
Is Nyambe back in the meeting?
Yes, please, I'm here.
Okay, welcome back. That is what the R squared measures. What about the adjusted R squared? The adjusted R squared has got the same interpretation with the R squared, only that this is how different they are. The adjusted R squared, it shows the same as the R squared, but adjusted by the number of cases and the number of variables. When the number of variables is small and the number of cases is very large, then the adjusted R squared is closer to R squared. It provides the more honest association between X and Y. So this one, it has got the same interpretation. So most of the times when you're interpreting the output, you don't usually interpret the adjusted R squared. Now, but the difference between the two is that, just as I said, practically, when you have the R squared, like this one, this R squared, you know how the R squared behaves. If you add, you increase the number of n, it keeps on increasing. You're following, right? That's the adjusted R squared. It keeps on increasing even if, or the number of variables, even if the variable that you have added does not have significance to the model. Did you get it?
Mm.
That's the weakness of the R squared. The R squared will be increasing. The more you increase the number of the variables, it keeps on going up. But when you examine the impact of those variables on the model, they don't even have an impact, but it keeps going up. Now, the higher let me score that, the higher the R squared, the better. Because we want more of variations in the Y variable to be explained by X, isn't it? Like the level of association should be up. It should be over 90% if possible, even the better. At least it should be above 85%. That's the level of association. Okay. Between
Yes,
X
please.
variables and the Y. But in this case, you find that the R squared is somewhere what? 63%. What does that mean? It means that what is 100 minus 63? 37, isn't it?
Mm.
So it means over 37% of the variance in Y, the X variables are not explaining. So the X variables do not account for 37% of variance in Y. That is a problem. That's a larger percentage. You're following, eh? Because that percentage, that 37%, it is unaccounted for. The variables are not explaining the variance in Y that is equal to 37%. So this variance will make the error term to grow, because all those unexplained, the disturbances, those errors, they will be captured by the error term. You're following, right? Those unexplained variations, they will be captured by the error term. So what will happen is that your error term will grow. Now, but the idea behind the ordinary least square, those estimators, is to look for the values, these coefficients, that can minimize the error term. We want to minimize the variances. So now it is working against our objective, isn't it? Right? That is working against our objective. If the X variables are just interpreting only 63, which means over 37% is not explained, and that 37% will go to the unexplained part. We will go to the stochastic variable, lifting it up, whereas our objective is to minimize it. So we have a problem. Okay. So by recommendation, the R squared should be above. It should be somewhere around above 85. It should be bigger in short. But it can't be 100 mostly. If you have 100, even the better, but it's not possible to have 100. Okay, but at least the closer it is to 100, even the better. Because we can say that, oh, our X variables actually, they are explaining a lot of what? Variances in the Y, which is better. That is what we need. We want the X variables that we have chosen to be able to explain as much as they can of the variances. Remember, they are there to explain the variances in Y. Is that clear? Hello?
Yes, it is.
Yes. So that is the weakness of the what? The R squared. Therefore now, adjusted R square was introduced. The one that takes into account those insignificant variables, those variables that have no impact, that just make the R squared increase. You understand, right? Those variables that don't have an impact. So it drops, it does not account for them. Sorry, it does not count their impact. How should I say it? Like the adjusted R squared is aware that some of the variables here are redundant. Okay, they have no, they are not useful to the model. So what it does is that it just takes into account only the what, the impactive variables, the meaning variables. That is how the adjusted R squared works. Is that clear? Hello.
Yes.
Yes, it is, please.
Yes. So that is how that is interpreted. So I've said the rule of thumb. The p-value should be less than 0.05. That is the level of association between X and Y, the level of significance between X variables and Y variable. If you reject the null hypothesis, it means that there is a significance, right, between the X variables and Y variable. The R squared should be upward. Okay, but there is this point that is very, very strong and important that I made. I said that the R squared and adjusted, they have the same meaning. But the R squared, it is adjusted for the number of cases and the number of variables. Okay, look at the way how they will behave. This is how they will behave. When the number of variables the number of variables is small and the number of cases is very large, that's the number of observation. The number of cases is very large and the number of variables is small. Okay, small variables, not just too many variables. Then the adjusted R squared will be just closer to the R squared, very close. Okay. The number of cases is higher than the number of variables is small, right? Yeah. When the number of variables is small, this R squared will be closer to each other. Now, how do you test the goodness of fit or of the model? You use the what? You use the R squared. The closer it is to 100, the better it is. Okay? Is that okay? Hello?
Yes, please. It is.
Yes.
We're here.
So for interpretation of this one, at least we have done, yeah, I wouldn't say 100%, but it should be 98 something. So we can, on this question interpreting, we can end here on interpreting part. But see, in the next lecture, I should be able to show you now how to calculate these numbers. The adjusted R squared, the R squared, how to calculate them. The P values, how do you calculate? You have to calculate them. But that will be an interesting conversation indeed. And I will interpret this part. This part doesn't really need to be interpreted because all this, it moves to this part. That's what is more important. We'll talk about it. Okay?
Okay, please.
Don't get tired of learning. Let's have this one. Let's have this one. They have the same meaning. I don't want to come next time and talk about just things that are same. You can tackle also this question because they are just too much related. They're just almost the same, right?
Okay.
Question number
This
4.
one is okay, please.
This one you can easily do it, isn't it? Or we leave it as an exercise. Right?
Yeah, let's do it.
Interpret the coefficients. You know how to interpret the coefficients, isn't it? That's what we're just talking about.
Mm-hmm.
So the regression is of the impact of schooling and cognitive ability of a respondent on what? On earnings. The impact of schooling and the cognitive ability of a respondent on earning. Is that clear? That is so the X variables are schooling, this is schooling, and the cognitive ability of a respondent, that is this one. On earnings, the earnings at Y variables, they are the ones that we're doing what? We are those are our Y variable. That's our Y variable, isn't it?
Mm-hmm.
Are people tired? No, sir.
No, we are here.
They are not tired, sir. So let's interpret exercise. Anyone? It's just similar to what we were doing previously. Interpret the coefficients. Your beta naught. What is your beta naught first? Your beta naught is negative 4.62, right? Plus 0.15 x1. Let's say x1 is the cognitive ability plus 0.74.
73.
Yes, x3 plus the error term. You can interpret this model. Can do. Interpret the coefficients.
Okay, like holding all other variables constant. The constant variable is the minus 4.62. Mm-hmm.
Hello?
Okay, like holding all other things constant, all other variables constant. In this case, it will be this earnings on schooling and the conjugal, that same thing, ASVAB, the constant amount, the constant units is at minus 0.62.
Okay, thank you very much. So you cannot say, you can say when they are zero, specify, don't hold them constant. Say,
okay,
when the X1 and the X2 are zero, meaning the schooling and the cognitive ability of the respondent are zero, then the earnings reduce by negative 4.62 units. Is it?
mm-hmm.
Yes.
That's
Let
a
us
beta
hear
note,
the
no?
sign. Yes, that's a beta note now. Let's see here the sign. So I've interpreted the beta note. You can interpret the other variables now.
Just come again, I was disturbed.
Okay. I'm saying for the constant, you can say when schooling and the cognitive ability of a respondent is zero, then the earnings reduce by negative 4.62 units because it's negative. Then you can respond, you can respond, you can interpret the coefficients. Pick one and do the justice.
Okay. So beta 2 schooling, it's 0.73, 0.74. So holding all other variables constant, an additional earnings on the number of schoolings will increase by 0.74.
Sorry, what did you say?
Beta 2. Yes. So
yes, madam.
Holding all other variables constant.
Yes.
An increase in the earnings on schooling will increase by 0.7.
Okay, I didn't hear what is increasing. You said an increase. An increase in what?
In the earnings on schooling.
Okay.
Is it earnings
So
on schooling?
you have reversed the model, because when you say an increase in earnings on schooling, it means that earnings are now the X variable, right? Impacting schooling.
Okay.
You get it?
Okay. It's schooling. Okay, which increases. Okay.
Impacting the earnings. So just as you interpreted it, it's okay. You can say now an additional unit increase in schooling
will increase your earnings.
We increase the earnings by 0.74 units. Okay. Is that okay?
Yes, please.
This is what is there. Observe that strategically, I'm not using percentages because these are not logged variables. Don't do it. Can't just say, no, they mean the same. So I'll say it increases by 74%. No. Someone who knows, but what do you mean? You get it, right? A level to level, you use the units. You can interpret the next one, any other, the second interpretation, a coefficient. Okay, for the cognitive ability, you can say you hold all other factors constant, right? You hold all other factors constant, holding other factors constant, and a unit increase in the cognitive ability of a respondent will increase the earnings by 0.15 units. Is that clear?
Yes, please.
Okay. If that is clear, then that's okay. Question number 2 says R squared. Can you interpret the R squared? I'm just from interpreting the R squared the previous slide. Interpret the R squared. Anyone? Which is 12%, right? Okay. So you can say that only 12% of variance in earnings is explained by what? By schooling and the cognitive ability of a respondent. That is a more specific interpretation. If you want to be general, of which you should not, you can say only 12% of variance in Y is explained by X variables. That is so general. You shouldn't.
Come again on the first one.
So only 12% of variance in earnings are explained by schooling and cognitive ability of a respondent. Is that clear?
Yes, please.
Which means over 100 minus 12 is what? See 88, right?
Mm-hmm.
Which means 88% of variance in Y is not explained, of variance in earnings. It's not explained by these two variables. The problem, the model has a problem, it's not dependable, understand? Because these variables we have chosen, they just explain too little of the percentage of variance, right? Too little. We need them to explain much, okay?
Okay, so therefore, what does it mean if only 12% have been explained?
It means that
How
only
does it-
12% of the variance in Y,
Mhm.
which is the earnings, is explained by X variables. Only that. Which means the remainder out of 100 is not explained. So that remainder will be in the error term, right? Will be accounted by the error term. So the error term will be bigger. But the idea is to minimize the error term. So you don't need a too small R squared. Make sure that at least the R squared should be bigger. You understand, right?
Yes, please.
But in your interpretation, you don't say all those things. I'm teaching. That's why I'm saying all this. In your interpretation, you just say only 12% of variance in earnings are explained by schooling and cognitive ability of a respondent. Remember, you've heard I'm mentioning the X variables clearly there. Yeah.
All right.
Okay. Any question? There is no question, sir. We are fine. B says this test and formulate the null hypothesis for what? For coefficients. What does the null hypothesis say? So the null hypothesis says that these what we're testing them. It says that these have no impact, right? Which means schooling is such that beta naught or beta, not beta one, but H naught, which is the null hypothesis for schooling. H naught should be equal to what? To 0.74. Now, when you say this is equal, you mean that it has got no impact. You understand, right? It is equal. Like the H naught is equal to that. Where you say that the H naught is that beta is equal to that. You mean that, how should I say, sorry, let me rephrase it. The H naught, which is the null hypothesis, is that this beta, right, beta hat, the original beta, the expected beta, is equal to the coefficient beta. They are equal, right? Which means they are the same. Like there is no difference. If they have no difference, it means that they are not they are not impactive to the model, right? It means that this variable has no influence. That's the null hypothesis. The null hypothesis simply means that this variable has no impact on earnings, right? So when you go using the p-value, you can just use any of them, they are consistent, but using p-value, you can see that the p-value is less than what? 0.05, which means we reject the what? The null hypothesis, right? If we reject the null hypothesis, it means that schooling has an impact on earnings. Did you get it? The null hypothesis is that it doesn't have an impact. Okay? That's the null. So when you reject it, it means that it has an impact. Doing the same on cognitive ability, you can see that the p-value again is less than 0.05. You reject the null hypothesis again. That says that the cognitive ability of the respondent doesn't have an impact on earnings. You reject that, which means that it has an impact, right? It is statistically significant to the model. And also the constant is significant. Is that clear?
Yes,
hello. Okay, so the last question is to do the goodness of fit test. Do the goodness of fit test. The goodness of fit test is tested using the R, the R squared. The one that you have just interpreted. So these questions are linked, right? This one you interpret, then you formulate the hypothesis here and test. Then the R squared is the one that measures the goodness of fit. Okay. So this model doesn't have the goodness of fit because what? Because only 12% of variance in Y is explained by what? By X. It's not a good fitness of fit. So when you say do goodness of fit, in short, like what test are you using? You use the R squared. That's what you just want to hear. These are more marks given for free. Okay? Is that clear? So if this one is the higher, I said this one should be above 80%, closer to 100, meaning the goodness of fit, the variable have got the goodness of fit, right? The distribution. Then if it's this like this, it doesn't have the goodness. It's not a goodness of fit, right? It's not good because it is not explaining the variance, a good number of variances as it should.
Sorry, come again. You are saying that